And hello, and welcome to today's panel debate on MES systems and AI within the factory. The panel explores how MES and AI, particularly large language models, are transforming PCBA manufacturing. Experts will share the latest developments, practical use cases, and proven strategies for integrating AI to optimize production efficiency, improve quality, and drive smarter decision making across modern electronics assembly facilities. To help me discuss this matter today, we've got a great panel. To my extreme left, we have Jared Evans from Arch Systems. Next to him, we have Andres Zerfas from ITAC Software. And then to my left here, we have Hugo Leite. So welcome, gentlemen. Thank you for joining me today. I'm going to get straight into the first question. Before I do, I want to share with you a graphic that I saw a couple of days ago on LinkedIn, and I asked the person who created it permission to show it today, and she very kindly agreed. Here it's on the screen, and it's showing the hopeful AI vision on the top, which is, of course, the guy sitting in the shiny offices talking about agentic AI, generative AI, intelligent automation, and robot workers. But below them we have the mind gap, because we've got all the issues like data silos and inefficient processes, manual processes, lack of government, and application sprawl. I mean, these are all typical things that we've got going on in the background. It's there's still a long way to go before we get a really smooth AI process that's going to be plug and play, as it were. My first question. What are, let me see, MES platforms have always been the backbone of the factory. How is AI, especially large language models, shifting MES from being a data recorder to a true decision-making engine? Let's start off with you on that one, Jared.
Okay, yeah, thanks very much. Arch System, we're not exactly seeing a lot of our partners and other companies in the industry move in that exact direction. I think aren't just the data recorder, like you said, but are able to give more insight and more direction to workers and things like that on the plant floor, which the AI models can be very helpful with.
Right. I mean, Arch Systems is it kind of bolts onto the side of MES. But it does do some of the data crunching. Is that correct? Is that how it works?
Yes, for sure. We provide connections directly to equipment and then transform the data into one standard messaging system that can go up and be consumed by an MES, also is consumed by us, and then we also consume MES data as well as part of that model.
Okay. Okay. So, Andres, do you have a view on this?
Yeah, sure. So ITAC Software, as a typical MES vendor, is currently developing an IoT platform, industrial platform, which will then gather all the applications necessary to exactly do what you are describing. So AI is an interesting word, it's an interesting approach, but you have so many approaches, and we are using LLM to make it easier for an operator to interact with the application, to find easy answers out of the huge data set, the data treasure that we have, including the MES data, operating manuals, also standing operating procedures, for example, to bring it all together.
Right. Well, that's where the true magic comes, is being able to crunch all that data and then send back actionable insights to the operator back on the ground. What is your do you have anything to add to that, Hugo?
Yes, as well. So we at Critical, we believe that there are three foundational pillars to have a real smart factory that rely both on MES, connectivity, and the data platform, so that AI can really extract value from what is happening on the shop floor. So MES, this is not about a shift from a reactive system to a system that will provide only insights. MES will still sit as the digital backbone because we need those digital records from what is happening on the shop floor. Once there's no AI model that can be built with success without quality data. And the role of the MES here is to give the context to some of the isolated data points that we are getting from the shop floor. Then the LLMs unlocked a true power, which is talking with data in our natural language and get clear informations and directions to our guys on the shop floor so they can act on the problem or the thing that they want to improve.
They want to, okay. Now, Ryan, I don't know if you can hear us, but basically, have you got an answer to that question there that differs from what any of the panelists have said so far?
Sorry, Trevor, if you wouldn't mind just repeating the question. Slight delay.
The question was, MES platform have been the digital backbone of the factory. How is AI, especially large language models, shifting MES from a data recorder to a true decision-making engine? Did you hear that?
Okay. I did. Thank you so much. Yeah. So for us, LLMs we're applying it, first of all, there's actually a big lift. You've got to bring on a model context protocol server to map to your specific state of data, your data fabric to say, and then leveraging the LLM. Getting that MCP server just tuned has been a key thing. Now, what we can do is onboard operators, engineers faster on the tool. We've always had a short onboarding cycle in terms of training to bring it on. But yeah, as you know, MESs can have a sizable footprint in the factory. So that's the value of an LLM for now that we see. On the analytics side, it's really about picking up the insights that are outlier detection. So we're still providing traditional machine learning for outlier detection statistics, and now just bringing this MCP model context protocol server in play to pick up on that. And that's really where we see the value. It's huge. Third one, which is really interesting, is that LLMs can actually free up your customers to write their own custom apps very quickly, right? It's once again, you've got a good mapping to the system. And so that's where we see this third value and something we're exploring further, because we do know a lot of our customers have unique issues and write APIs around our solution.
But I'm going to head back now to Jared over here and ask, what are some of the most successful real-world examples of AI-enabled MES, improving yield or reducing downtime or accelerating root cause analysis in SMT or test operations? Can you give us a couple of examples?
Yeah, two that really stand out that we've rolled out with our customers is one, we use an LLM to help with automated downtime labeling. So we'll take in data from the equipment, including fault codes, when the equipment was down, any surrounding information around the product that was being made. And we can also take in comments from operators, and then the LLM can assign a downtime reason based off of that for downtimes that aren't coming directly off of the equipment. That's really helped customers label more downtime and make the operators less afraid of getting something incorrect. They just have to worry about, I'm going to give a comment, and that'll turn into an actual reason. So you label more downtime, you're able to root cause more downtime. That means you're able to reduce your downtime. So that's been really successful for a number of our customers.
Okay. Andres, you got a good example, maybe a different one, but another good example?
Yeah, sure. So a complete different example is in the area of MES usage, because MESs are very complex in usage definition configuration, and with our approach LLM we use our documentation so that a developer can develop quite easy and fast applications, adapters to get value out of the shop floor or out of the ERP world and bring it to our MES level. Right. So developing is split up, and we have also a downtime tracker to get with all the values around the possibility to hit exactly the condition, to learn what might be the condition, the issue of the machine. And this is a two-way mechanism, so give a hint what could be the condition, but then approve that this is really condition, and
Right.
the final state would be an automated way to just upload the condition out of all the values, the possibilities using LLMs.
It's an interesting one, the downtime analyzer. What's the maximum or the least amount of downtime you've been able to achieve after you've implemented your system?
So our approach is that after 3 days, it should be up and running for a certain set of machines. So after it is settled and the training is done, it should be an automated way for all the key users to know exactly how to use it and then to speed up integrating station by station.
Well, what's your target uptime now?
The what?
The target uptime. Do you have a target uptime?
3 days,
3 days?
for the whole system
Yeah.
until we have the first conditions up and running and uploaded.
Okay. Okay. Do you have any examples?
Yes, I will go to the machine learning one as well. So that's one of the examples that we are also showcasing here. By collecting the data telemetry and also the process data from material movements on the shop floor, correlating that with test and inspection equipment, we are able to train a machine learning model with precise data sets and data points with the contextualized information from the MES, and correlating that with defects that are appearing with in more quantity, let me say like that, increase of a specific defect. And based on that, we can train our model to then send back to the technician, for example, that they should go to the line to adjust this specific process parameter that is the one that is causing this specific defect. Right. On top of that, on the analytics part as well, interacting with instead of shuffling from dashboards and reports to get, for example, information about why yield dropped on a specific line. We are using an LLM so that you can query the system in natural language and get not only the information about where the yield dropped and the potential root causes for that.
The root cause. That's interesting. Okay. We'll come back round to you again, Jared. So how do you think AI-driven MES tools are going to change the role of engineers and operators on the shop floor? And will it empower them with better insights or risk creating an over-reliance on the automation?
Yeah, I think it's always a good question to be looking at, are we creating over-reliance on a tool? Are we taking away opportunities for an operator or an engineer to learn the process? But I think what I see a lot of times is we have so much data in the factories already. And if it was just a case of looking at one more dashboard or having one more analytics tool by itself, it already would have been created. And we already would have had the factory running more efficiently, right? Sure. So I think a lot of these process engineers and operators, they're looking for, hey, I know what to do when certain things happen, but I need more information, or not more information, but I need that information distilled to me a little bit better so I can make a good decision. And I think that's where the LLMs can be very, very helpful, is looking at that broad set of data that no human could ever analyze in the right amount of time to make a decision on the manufacturing floor. Instead, they can get it presented to them and then use the skills that they have and also rely on the LLM to problem solve with them to get manufacturing back on track and moving forward on schedule.
So a real work assist basically role. Okay.
Yeah, exactly.
Andreas, do you have a view on how it's going to change the engineer's role, the operator's
No, definitely not. So the first statement I would say, the engineers will not be exchanged or substituted by AI in general, but they will be supported by AI.
Right.
They will get much faster information that they need because we have these different silos. They are brought together. The information is brought in a visually way with natural language that they understand in different languages. So German, English, French doesn't depend. You do not have to translate it. So the knowledge that you have gained in the US or in England can be used in Italy as well. So there's no transformation necessary. And this is, I think, the best thing that you can use at the beginning. That is not, it's also important, I think, to say that LLMs will directly use agents to control the machine. I think this will be a step somewhere in the future. But in the first step, engineers will be supported. I think that's the most important thing.
It's an interesting point you make there about using the data that you pick up in a factory here in Munich, for example, and applying it to a factory in Malaysia or that. But I mean, very often the conditions, the environmental conditions are very different, and you get different, and paste behaves differently, and things are different. Do you find when you have a lot of installed bases, Jared, over the world, are you using data that you're pulling out of Asia on factories in the US?
It depends on what type of data. I think I agree with you in terms of sometimes your operating conditions are very different, one locality to another. But at the same time, a lot of the processes are the same, and you can take good learnings from how you run a process, just like you were mentioning, Andreas. And I think it's a great point. I'm very lucky to be on a panel with many multilingual people here, but that's not always the case in the factory. You're having one operating language in the factory, and then your headquarters is completely different. How do you get that feedback on what's working on a process back to the rest of your company? I think the LLMs can be a huge help in that, and it's not dependent on the operating conditions and environmental conditions so much. It's about what the engineers are problem solving.
Right. Okay. So Hugo, any thoughts on how this is going to change the operator's life?
Yes, so first I have to say that there are many different points of view in this topic, but I align on what my panel debate colleagues just have mentioned. So I truly believe that the topic here is that LLMs will not exchange the people on the ground. They will augment their capabilities by removing the need for some repetitive and manual tasks, reporting, dashboarding. But they will not replace them. The dependence on LLMs only appear if we are just relying on the recommendation and we don't understand the why. Then you can create a dependency. So it's really important that when we are seeing a recommendation or a direction from someone, we need to understand the reason behind to build the trust, and also to start the necessary iterations for the model itself to become really robust, so that we can trust it even more. So
I agree.
think it's about that.
Yeah, it's an important point. Okay, I want to move on to my next question, which is with AI models now interpreting production data, what safeguards are essential to ensure data accuracy, model transparency, and cybersecurity in a connected factory ecosystem? I'll start with you on that one, Hugo.
So, in our case, we first believe in freedom of choice. So it all starts on picking the right LLM. So we do believe that manufacturers should be able to decide either from the most commercial one or from a local hosted LLM, so they can feel confident with the choice that they are making.
Right.
Then on data access and the data governance, instead of providing direct access to the database, we are using OData endpoints, so that we are reducing on one side the risk of LLM for hallucinations, and also for data leakage, and this also applies internally. Then on the cybersecurity part, this data access policy, this possibility to run a local model, plus having in place authentication mechanisms between clients and servers, we believe that this gives the manufacturers the trust and the choice, so they can be more safe, let me say, in getting the right conditions to have secure AI implementations and data access in their factories.
Okay. Andreas, do you have a thought on the security of this, the security of the data and the cyber security? Of course, a lot of customers, especially that are doing high-rel military or things like that, they're not allowed to have cloud-based systems. It's got to be on-prem.
That's exactly our strategy. So we have all the data that is accessible on premises. There is parts of the data that might be in the cloud, but primarily it's on premises, and we are running all the models, all the algorithms, all the LLMs then on the machine in the shop floor. And it's important that we do the validation of data. As has been mentioned already, it's necessity to understand what is clear proper data, what is not proper data. We need also knowledge graphs to understand what is the content, what is the structured data that we have inside to provide clear and proper answers. And I think this brought together is very important to establish a system that helps and brings value out of a real big unstructured world.
Right, okay. So, Jared, I mean, unless you've got something different to add to that, I'll move on to the next question. Or do you have something you want to add to that last one?
I think that was covered very well. So, yeah let's move on to the next question.
So the last question then is, looking ahead, how close are we to a truly autonomous, self-optimizing SMT life? I mean, I lost my place there. Yeah, and what needs to happen technologically and culturally before that vision becomes a reality? Okay.
Yeah, I can talk to that a little bit. Our data science team at Arch Systems actually did a study comparing outputs of different LLMs versus industry experts on problem solving with SMT data.
Yeah.
And one thing that we found was if you're just putting data directly into a commercial LLM off the shelf, like a ChatGPT or things like that, the results were not great compared to an expert in SMT. They were okay. They would say, oh, try this, try that, but they weren't really giving depth that an expert would. So I think it's really important as we move forward as an industry. What we found was creating extra context, structuring the data properly, making sure that the AI had memory of what was asked previously was really key to getting answers on the same level as an SMT expert. And so I think that's where some of the things that you need to do in the plant to be able to get to that sort of fully autonomous SMT line are work with your vendors to provide that expertise, work with your partners to provide that expertise on their equipment, on their systems, because it takes an entire ecosystem to create that expertise and drive it in the plant floor. So that's what we really preach to our customers.
Yeah, I think some of that work you were doing, looking to try and capture some of that knowledge was really, you were trying to capture some of the tribal knowledge from some of the older people in the factory. And I actually had a discussion with Andrew about this a while back, and I said that I thought the best way would be to have a body cam, basically on the engineer, so that when he was asked to go out to the line to fix a machine, he went out there and he just narrated what he was doing, you know, and do it that way. But who knows? Anyway, Andreas, do you have a view on this?
Yes, sure. From our point of view, MCEPs, for example, are a good approach as an adapter to bring the data into systems that maybe we do not support, but we want to support the mechanism in general.
Yeah.
But when you bring it to the other world, so to say, you need some kind of metadata. You need an information, something like uniform namespace, which is currently not completely available. There are old structures available, but currently the situation is slightly different. No. And when you really want to bring something to a lights out factory, something like this, you need such a mechanism to be sure that everything is comparable and that the answers that you provide are the same for every system.
Right, I'd agree. Final word to you, Hugo.
Yes, so going back to the first graph that you put there, I think that's one of the answers for these questions. That's still a lot to unpack on that direction. Then on the technology part, MCP, RAGs, and so on, for sure that needs to be put in place so that we can have this unified system with the safeguards necessary, that we ensure that the quality of the data is the one that will drive the intelligent running on the shop floor. And at the end, I don't believe this will be some kind of a collection of parts. It's about the unified ecosystem that was made by this purpose. So it's not by collecting small parts of software, for example, but as a unified ecosystem that was built with this purpose of this autonomy.
Okay. And I think the final remark I would make on this is that here in Europe especially, we need to get further clarification on the guidelines and regulations around AI. because at the moment they're still a bit furry, and we need to get proper guidance on how that's going to work, so that people can develop systems. Anyway, gentlemen, great debate. Thank you for coming in and talking to us today. Thank you to Jared Evans from Arch Systems, Andres Zerfas here from ITAC Software, and of course Hugo Light from Critical Manufacturing. So thank you, gentlemen. Thank you to Ryan Gamble, who unfortunately had to leave us, but he will be joining us later next week. And thank you to our audience for watching today.